next we are going to discuss the condition for dilution or how to derive a formula for dilution. Okay, very simple to understand. Now just we have seen here that during dilution, what was remaining constant? We learned that number of moles of the solute was remaining constant, or amount of solute was remaining constant, or number of gram equivalents of the solute was remaining the constant. Okay, so I can say before and after dilution, number of moles of solute remains the same. So I am trying to express in terms of number of moles of the solute. And I know that molarity is defined as number of moles of the solute divided by volume of the solution in liters. Okay, so tell me what is number of moles of the solute then? Number of moles of the solute is equal to, so I am cross multiplying here. So you can see molarity multiplied by volume of the solution in liters. Correct. So and now I know that before and after dilution, what is remaining constant? Number of moles of the solute remains constant. So this value should be fixed one. Okay. So now I can say M1 V1. Okay, so M1 means molarity M1 and V1. So these two are multiplied, then what I will get? Number of moles of the solute. So let me say before dilution. This is the case of before dilution. So before the dilution, the number of moles of the solute can be represented as M1 into V1. Correct? Now we know that after the dilution, what will still remains the same? Number of moles of the solute remains the same. So can I say that after dilution it is again M1 V1? No. Why? Because I know that after the dilution we are adding solvent into it. So that means the volume of the solution is increasing. So let me say V2 will be the volume of the solution in that case. So if this is V2, I know that the product of mass, product of this molarity and volume should be always the same because number of moles is constant. So I can say molarity is changed to M2. Okay. So I can say this product will always remains the same. M1 V1. For example, I say 5 into 4 is 20. Okay. I can write that as 4 into 5 also. Or 2 into 10 also, but always the product is 20 only. So similarly, I can say number of moles of the solute is constant because that is the condition for dilution. We have seen why it is like that. Now we say that number of moles of the solute can be expressed in terms of molarity and volume of the solution. And I know that after dilution, volume is going to increase. So that means V1 is a lower value and V2 is a higher value. So if V1 is a lower value, then I can say M1 should be higher. Then only M1 V1 will have a fixed value. Now again M2 V2 is also having the same fixed value, but V2 is here higher, then surely M2 should go down. So I can say here V1 is less compared, V1 is less. What happened to V2? Increased. So V1 is less compared to V2. And comparing to M1, what is happening? M1 is here higher and M2 is here lower. Because why? Because the V2 has gone up. And the product will always remain the same. This is how we are deriving the condition for dilution. So we can say that during dilution M1 V1 is equal to M2 V2. Clear? Now listen here. We can also represent the same concept in terms of normality also. Now you know how it might be. We again know that mass of the solute remains the same, number of moles of the solute remains the same, and number of gram equivalents of the solute remains the same. So next I am trying to derive number of gram equivalents of the solute. Okay, so we know that normality is equal to number of gram equivalents of the solute divided by volume of the solution in liters. Now tell me what is number of gram equivalents of the solute. So number of gram equivalents of the solute is equal to normality multiplied by volume of the solution. Correct? So I know that number of gram equivalents of the solute before dilution is equal to number of gram equivalents of the solute after dilution. So here I am just correcting before and after dilution, what will remain the same. So since I am representing in terms of gram equivalents of the solute, I am writing in terms of gram equivalents. I can say number of gram equivalents, number of gram equivalent of the solute remains same. Correct. So three factors remains the same. first weight in gram of the solute, number of moles of the solute, and number of gram equivalents of the solute. So number of gram equivalents of the solute is equal to normality n into volume of the solution in liters. So I know that before the dilution, number of gram equivalents of the solute has a fixed value. Let me say n1 into V1. Okay. Now after dilution, still the value remains the same. Then I can say that equal to N2 V2. Why I am not writing N1 V1 again? You know that after dilution, volume of the solution is increasing because we are adding solvent. So V1 increased to V2. So V2 increased means N2, what should N2 do? It should decrease so that N2 into V2 should be equal to N1 into V1. Then only the concept hold good, because the number of gram equivalents of the solute remains the same before and after dilution. So I hope you understood the condition for dilution. One is M1 V1 is equal to M2 V2, and the other one is N1 V1 is equal to N2 V2. Okay. Next I am introducing you the concept of mixing of solution. So earlier we have learned concept of dilution, where you are adding a solvent only to a solution, correct? Now you are mixing two solutions. Okay, both are different. In the earlier case, you are mixing a solution with a solvent. That is called a dilution. Mixing of a solution with a solvent is called a dilution. Now you are mixing two solutions. So that's why you can say in the first one you could see solvent is there and three solutes you can see. This is again for your understanding. And here also you can see solvent is there and the solute also you can see. So here I have taken both an acid solution. Okay, both are of same pH nature. Both are acid. So resulting will also be an acid solution. Okay. Now we assume that its normality is N1 and its volume is V1. Okay, and this one has its normality N2 and volume is V2. Okay, and the resulting solution has a normality NR and the volume will be what? When you add these two, the resulting volume will be V1 plus V2. So I write V1 plus V2 here. Okay, now please understand, please think about it. When you mix these two, what remains constant? Again, the same concept. You know that when you mix these two, volume of the solution is going to increase. You could see here, this is added up with this one, so that net volume becoming this one. And what is remaining constant? I can say when you mix these two, I can say the number of solute is getting added up, correct? Because if it has three solutes here you could see three solutes, and when you are mixing, the amount of solute gets added. So that means it becomes 6. So I can say amount of solute, that is, it can also be written as number of moles of the solute, correct? So if I say in terms of number of gram equivalents of the solute, just now we have seen number of gram equivalents of the solute is equal to what? Normality into volume of the solution in liters. So I can say this is N1 into V1. N1 into V1 is what? Number of gram equivalents of the solute of this one will get added up with number of gram equivalents of the solute of this one, that is what? N2 into V2. So when you add these two will get added up for which one? This solution, final solution. So I can say final solution, the number of gram equivalents of the solute, that is NR into V1 plus V2 will be equal to the sum of number of gram equivalents of the solute of first solution plus the number of gram equivalents of solute of the second solution. So this I have written in terms of normality and volume of the solution. So I can say number of gram equivalents of the solute of first plus number of gram equivalents of the solute plus 2 is equal to the number of gram equivalents of solute of the third one. So number of gram equivalents of the first one means N1 into V1 plus number of gram equivalents of the solute of second one means N2 into V2. This will be equal to number of gram equivalents of the solute of the third one, that is NR into V1 plus V2. So this is the formula you need to apply for what? During mixing of solution. So I can say net normality is equal to what? N1 V1 plus N2 V2 divided by this, you can take it on the denominator, it becomes V1 plus V2. Understood? So I have explained the formula in terms of what? Number of gram equivalents of the solute, and I know that it can also be represented as number of moles of the solute also, because what is there, how we say number of moles of the solute of this one will get added up with the number of moles of the solute of this one to get the number of moles of solute of the final solution. So I know that number of moles of the solute is what? Molarity into volume of the solution. We have seen just before, correct? So I can say molarity of the resulting solution into V1 plus V2. This is what molarity into volume of the solution means. This is my number of moles of the solute is equal to molarity of this one, that is M1 V1 plus second solution molarity M2 V2. So this is the other way of representing it, because in exam they may say first solution in terms of normality and second solution in terms of molarity. So you know how to convert normality and molarity to each other. Okay, that also we will see the relation between normality and molarity. So if they given the complete thing in terms of molarity, you can use this formula to find the molarity of the resulting solution. If they give normality, if they are asking you the net normality of the resulting solution means, you can use this formula. Okay, I hope you understood the concept of dilution and concept of mixing of the solution. So very simple, I am finalizing it. During dilution, what remains the same before and after the dilution? The number of moles of the solute, weight in gram of the solute, or the number of equivalents of the solute, all are the same. In different way I am representing, but the amount of solute or the number of moles of the solute or the number of equivalents of the solute remains the same. And what happens during the mixing of the solution? During the mixing of the solution, these number of moles of the solute or the number of gram equivalents of the solute or amount of solute will get added up to get the final number of solutes. So that is what the concept of mixing is about. From that we are deriving the formula in terms of normality and molarity. I hope you understood a rough idea on this concept. Now one more thing I need to point out. Here acid solution is mixed with the acid solution. That's why I have added up here, because both is going to added up in the final solution. But you know that if I am taking one as an acid solution and other is a base solution, this is not going to add it up. Why? Because this will undergo neutralization. Acid will react with a base to form a salt. We learned this in our early classes. That is called a neutralization reaction. In that case, what will be the formula? I can say the formula will become NR into V1 plus V2 is equal to N1 V1 minus N2 V2. But here you will have a doubt, sir, why we want to subtract N1 V1 from N2 V2? That depends actually. Which one is having higher value, N1 V1 or N2 V2? That you should subtract from the other one. Okay. Similarly, this will become MR into V1 plus V2 is equal to M1 V1 minus M2 V2 if M1 V1 is greater than M2 V2. Okay, that we will derive in the next session. Okay, so next we see the concept where it is again the concept of mixing of the solution, but here one solution is an acid solution and other solution is a base solution. Just now I have told an acid plus base react so that it is a neutralization reaction, so that you will get salt or something. Okay, so here you could see here on mixing these two, I can say this will undergo reaction with this one, so that the number of moles of the solute is never going to add it up. It is going to decrease. But again I can say that these are of two types. Neutralization reaction can be incomplete neutralization or it can be complete neutralization. What does that mean? Complete neutralization means the complete acid solute is going to neutralize complete base solute to form the salt. So that N1 V1 is equal to N2 V2. In that case what will happen? N1 V1 minus N2 V2 will become 0. That is called complete neutralization. Incomplete neutralization means N1 V1 or N2 V2 will be higher than the other one. So here I am assuming N1 V1 is greater than N2 V2, so that you will get some value for this subtraction. That is called incomplete neutralization. Okay, so again the same formula I am writing, only difference is minus will come into picture. So initially you might not be knowing whether it is complete neutralization or incomplete neutralization. On substituting these values, if it is getting to 0, this value N1 V1 minus N2 V2 is becoming 0, then I can say it is a case of complete neutralization. Suppose you are getting some value out of this, N1 V1 minus N2 V2 is you are getting a positive value, then that means it is an incomplete neutralization where N1 V1 is greater than N2 V2. Okay, suppose if you are getting a negative value, what does that mean? It means N2 V2 is greater than N1 V1. Okay, so this is the concept of mixing of solution if you are taking an acid with the base. So please remember, if it's an acid and base, what will happen? Neutralization will happen. And if it is both acid solution, it will get added up. If it is both base solution, then also it will get added up. Both are the same. So I'm not explaining both are base. It remains the same. The formula is N1V1 plus, again both are same means plus will come. If both are different means minus will come. This is what you need to remember. So I hope you understood what is this one. Okay. So next we will discuss some of the problems from this areas, concept of dilution, and then we go deep into the chapter, the next concept, that is called solubility. Okay. I hope now you know how to express the concentration of the solution in different terms, concept of the dilution, concept of mixing of solutions. Okay.